So we're doing 1.6b. Absolute value inequalities. So in this chapter so far, we did just solving equations of regular stuff. Then we did solving their inequalities. Then we did solving absolute value equations. Now we're going to do solving absolute value inequalities. And these are a little tough. They're a little tricky. Okay? And we have two parts today, and there's two types. There's when the absolute value is less than a number, and there's the absolute value when it's greater than a number. So those are our two. Okay? You got to get them sorted out so you don't mix them up. All right, so the first one we're going to do is when our absolute value inequality is less than a number a. So this is what I want you to do right now. So I'm going to give you an absolute value. The absolute value of x is less than 5. And I want you to write down on your paper just 3 numbers that will work. Plug a number in, check to see if it works, and then write 3 numbers down that actually do work. Okay? So try that right now. Just 3. 3 numbers that will work. If you're not sure, just pick a number, pick your favorite number, plug it in. Does it work? Nope. Okay, try a different one. So 3 numbers. All right, and we're going to plot some of these numbers. So who wants to give me a number that they chose? Anybody? Just shout it out. Yes.
-2.
-2. Perfect. -2 works here. -2 works, right? The absolute value of -2 is less than 5. What did you say? 4? 4 works too.
4 doesn't beat it.
4 is good. What else? Who else got a number?
3.
3? Perfect. What else?
2.
2? Mm-hmm.
1.
1? Mm-hmm. Oh, I already did 1. -2? Okay. 0, right? 1, 2, 3, 4, 5. All right. Will 5 work or -5 work? No. All right. So that's going to be our boundary. And if you might have looked and saw that all of our numbers are falling in between these. And so -5 doesn't work and 5 doesn't work, but everything in the middle does. Shh. Do you remember doing those problems the other day when we had the and? They came together. They're numbers that are greater than -5 and less than 5. So that's what happens for this inequality. And I told you that the absolute value is like the distance, right? You're talking about distance. So if I tell my kids, hey guys, we're standing on this line right here, and we're in this China shop or something, and there's all these China bowls everywhere, and I'm like, hey, like not the country China, but like China dishes. And I say to my children, you guys have to be at least 5 feet near me at all times in this shop. So they can go, if we're just standing in a line, okay, they can go 5 feet that way, and they can go 5 feet that way, but they can't go past it. Okay, they're confined to this amount of space. So what we say for x is less than 5, we say that -5 is less than x is less than 5. Okay, their value is greater than -5 and less than 5. So these are going to be our and problems. These are going to be the and. The other way that we're going to do in part B are going to be our or problems. So there's one and, there's one or. All right, so let's do some. I know, right? I have a whole bunch of them. Actually, I thought about that today. Yes. Right? 2x minus 1 is less than 7. Let's do less than or equal to. So the absolute value of 2x minus 1 is less than or equal to 7. Okay, let me tell you what this means. It means that this stuff inside of here has to be no more or, equal to 7 away. So basically what you do is this. You're going to take 2x minus 1. You're going to say that this stuff has to be greater than or equal to -7. I can't go past -7 because that's, farther that way. And less than or equal to +7. Okay? So you just put this stuff inside the absolute value in the middle, and then you bound it on each side. You say you can't go past -7 and you can't go past +7. Yeah.
So you wouldn't solve?
Yes, so now we're going to solve. So that's the setup. Yeah. No, that's the setup for all these and problems is less than. Less than 7 means I can't go past -7 and I can't go past +7. So now I want to find out what my x's can be. So I'm going to add 1, and when I add 1, I need to add it to all the parts. Remember, we did that a couple days ago. So I get negative 6 is less than or equal to 2x is less than or equal to 8. And then divide everybody by 2 so that you get negative 3 is less than or equal to x is less than or equal to 4. And that would be the correct answer. And then they're going to ask you to graph this on a number line where you would go negative 3, there's 0, there's 4. And we're going to be negative 3 is less than or equal to x, so we're going this way. And x is less than or equal to 4, so we're going this way, and it's all the stuff in between. And it includes them also, because it's less than or equal to. How do you like it? Is it easier than you thought or harder? Did I scare you? Okay, number 2, you try one then. You're so good at it. The absolute value of 3x minus 4 is less than 8. All right, you try this one. 3x minus 4 is less than 8. I'm going to pause. Okay, so we're going to set this up as 3x minus 4. This whole thing is got to be less than 8. So I got to think about distance because it's in the absolute value. So it's from negative 8 to positive 8. So there's the setup. You have to set that up correctly with the absolute values going, or the inequalities going the right way. Add 4 to everything. You get negative 4 is less than 3x is less than 12. Divide everything by 3. Ew, that was gross. Divide by 3, so you get negative 4/3, which is okay. It's not the prettiest of numbers. Less than x, less than 4. And if you're going to go to a number line and graph this, okay, we like to put 0 in the middle. I would go to, so negative 1, here's negative 4/3. Put an open circle. Go over here to 4, open circle, and all the stuff in between. Okay, it's not too bad when you just learn one thing like that. You can do the same thing every time. The hard part is when you learn the second one, and then you have to decide which one's which. That's the hard part. Yeah. All right, so we're going to do the absolute value of x is greater than a. All right, so let's think about numbers that would work in this now. If I told you the absolute value of x has to be bigger than 5, again, we'll stick with that same number. Let's go ahead and plot some points. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. Okay, so what numbers would have to go in here? Yes, you got it. Maddie's going like this with her thumbs. She's going out this way for both of them, right? So 6 would work, but so would 5.5, and so would 5.0005. So I'm going to go to 5 and put an open circle and say all these numbers to the right would work. And that's true. I plug in 6, bless you, I plug in 7. But you have to remember this is a distance. So here I am, really, this is more like me. I'm at my house and I'm like, kids, you're driving me crazy. Get at least 5 feet away from me. So they can go 5 feet that way, or they can go 5 feet this way. Okay? Because all those negatives will work because when you take the absolute value, it's going to be bigger than 5. So these are going to be our OR statements. All right, so here's how you write OR. You never combine OR into one thing like we did the AND. OR has to be separate. You're this or that. So you're either x is going to be less than negative 5, the small numbers, or x is greater than 5. You never combine that. Okay, split it up every time. And a lot of people like to memorize stuff like this. And so if you see this, this is going towards, and towards kind of sounds like or. I don't know, someone said that one time, that helped them a lot. Less than sounds like and. So those are the and ones. So let's do some. Here we go. Number, what are we on? 3? Number 3. Let's do the absolute value of 2x plus 4 is greater than or equal to 6. Okay. So you have to think of this as the entire absolute value has to be a distance more than or equal to 6 away. Okay? So that's two things. I need to say that 2x plus 4 can be less than or equal to negative 6. Do you see how I flipped the sign for the negative 6? The sign was going this way. I flipped it. It has to be less than or equal to negative 6, or 2x plus 4 has to be greater than or equal to positive 6. Okay? Once you have that, it just brings us back to what we did a couple days ago when we did our compound inequalities. All right, so subtract 4. 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. Or subtract 4. 2x is greater than or equal to 2. X is greater than or equal to 1. Okay? And they're probably going to ask you to graph this. And when you do graph this, you can see that it's an or statement because x is less than or equal to negative 5 going outwards, or x is greater than or equal to 1 going that way. Okay? Yeah. So your ands are going to come together and your ors are going to separate. You're this or that. You're going that way or you're going that way. All right, you try one. Let's see. Number 4. Number 4. The absolute value of 5x plus 10 is greater than 15. So all that stuff, that 5x plus 10 has to be more than 15. The distance has to be more than 15 away. All right, so set it up exactly like the last one and solve. The only hard part about this really, if you got it, you're doing great, is when they're mixed and you have to remember which way is which. Okay, less than, you're confined to a small area. Greater than, you can go outside past. All right, try this one. Pause it. All right, so I need to set this up as 5x plus 10. This expression inside my absolute value has to be less than negative 15. It has to be farther than 15 away. Or 5x plus 10 will be greater than 15 away. So you got to think about a number line. I got to go farther than negative 15, and I got to go past positive 15. And so I'm going to subtract 10, and I get 5x is less than negative 25. So x has to be less than negative 5. And I go over here and subtract 10, and I get 5. So x is greater than 1. Okay, so here's 0, here's negative 5, here's positive 1. Is that like the last answer?
Yeah.
How funny. Yeah. X is less than negative 5, or, and don't forget to write the word or. I almost forgot. Or x is greater than 1. Nice. Okay, so let me go ahead and we're going to do, I've got one more, kind of 2 more examples, but I want to show you something that happens. So if I have the absolute value, so these are some special things that can happen, some special cases. If I have the absolute value of something like 5x plus 1 is greater than negative 5, or if I have the absolute value of 5x plus 1 is less than negative 5. Okay. Something special happens, just like in your homework last night when you did solving equations and you got to equal to negative 5 and you stop and you say no solution because an absolute value cannot equal a negative number. So let's look at these. This is saying the absolute value is greater than negative 5. Well, when does that happen? When is a positive number greater than a negative number? All the time, right? So this would be, the answer would be all reals for this. This is everything. You don't want to split this up into an and or an or problem. You want to just simply say all the time it's going to work. Doesn't matter. No matter what you plug in, it's going to be greater than negative 5. How about this one? This is the other way, right? An absolute value is less than a negative number. How is a positive less than a negative? This would have no solution. Okay? So those are your special cases. So when you come across those, like this, number 5, and they show up in your homework and they don't tell you that they're showing up, they would do something like this. -3 times the absolute value of x plus 1 is less than 9. So you need to first get rid of that -3. Excuse me. And you get the absolute value of x plus 1 is less than -3. And then you stop. Okay? Anytime you have absolute value on one side, a negative, whether it's equals, greater than, or less than, you stop and you say, when is this absolute value going to be less than a negative number? And you say never, and you move on. And then you like those, because there's really no work to, you just have to think about it. Okay, we're going to end with one more problem.
Do we end with a special case problem?
No, that was our special case. We're going to end with a tough one. Here we go. I'll work it out with you. 3 times the absolute value of 2x plus 6 minus 9 is less than or equal to 15. All right, here we go. So just like when you solved your absolute value equations last night, do you remember how you had to get all the stuff around the absolute value over to the other side? Same thing here. Okay, so what's our first step in this problem? What are we going to do first? I heard it. Yeah, we're going to add 9. Add 9 over to the other side. And then you get 3 times the absolute value of 2x plus 6 is less than or equal to, what is that? 24. Perfect. All right, now what's next? Divide by 3. Yes, you got it. Divide by 3. Divide by 3. The 3's will reduce. Absolute value of 2x plus 6 is less than or equal to 8. Perfect. Okay, now here's where you have to decide. Is this an and problem or an or problem? Okay, so look at it. The absolute value is less than 8, smaller than 8. So that means that my expression inside of the absolute value has to be between -8 and +8. This is an and problem. We were doing or problems just a minute ago. This got switched to less than and. Does that help anybody? Less than. And towards is or. Greater than. Less than. All right. So now let's go ahead and solve this. Subtract 6. -14 is less than or equal to 2x is less than or equal to 2. And make sure you show all this work. Write the problem down. Work it out. So we get -7 is less than or equal to x is less than or equal to 1. So the answer is going to be numbers between -7 and 1, including -7 and 1, and that's it. Nothing else. And so if we wanted to graph this on a number line, -7, +1, and it's all the stuff including -7 and 1, and all the stuff in here. Got it? Good.